Welcome to class. Today let's talk about gas laws. Gas laws. Now, under gas laws, we will talk about Boyle's law. We'll talk about Charles' law. We'll talk about pressure law. We will talk about ideal gas equation. We'll also talk about general gas law or combined gas law. So I will just go straight to the point. What does each law state? And then the formula for calculating each law, and then we quickly look at the examples. Just straightforward. For the Boyle's law states that your pressure is inversely proportional to volume when temperature remains constant. Pressure is inversely proportional to volume when temperature, at constant temperature, pressure is inversely proportional to volume. So for Boyle's law, because pressure is inversely proportional to volume, if I change this proportionality sign, I will have P equals my constant, which is T. Okay, so let me use constant K over V. So if we cross multiply, I have PV is constant. So they can ask you at what point or what law is PV constant? That is Boyle's law. So if I want to derive the formula here, the formula for Boyle's law is P1 V1 equals to P2 V2, where P1 is equals to initial pressure, V1 initial volume, P2 final pressure, and V2 final volume. P1 is the first pressure, the second pressure, the first volume, second volume. So this is Boyle's law. Let's look at the Charles law. The Charles law states that your volume is directly proportional to temperature. Volume is directly proportional to temperature. So if volume is directly proportional to temperature, our Charles law states that at constant pressure, volume is directly proportional to temperature. So when the temperature, the meaning of direct proportional is that when the volume increases or the volume increases with increased temperature. The meaning of pressure inversely proportional to volume is that when the pressure is higher or increasing, volume will be decreasing. When the volume is increasing, pressure will be decreasing. They are inversely proportional. But when you say two things are directly proportional, both of them either increase together or they decrease together. So volume is directly proportional to temperature. That means when the volume increases, the temperature is high. All right, and when the temperature increases, the volume is also high. So because of that, since V directly varies as T, V is going to be, we introduce a constant, KT, so I'll divide both sides by T. So my V over T is equals to constant. So this is what you have for Charles' law. To derive the formula for Charles' law is going to be V1 over T1 equal to V2 over T2, where my V1 is the first volume or initial volume. My T1 is initial temperature. V2 is final volume, and T2 is final temperature. So we are done with Boyle's law So we're done with Boyle's law and Charles' law. Let's look at the pressure law. For the pressure law, this pressure law is also called Gay-Lussac's law. Gay-Lussac's law, that's pressure law. Now this law simply states that pressure directly proportional to temperature when volume is constant. So pressure directly proportional to temperature when volume is constant. So if we introduce constant, P equals KT, I'll divide both sides by T. Alright, so my P over T is constant. And the meaning of that is I can derive the formula is P1 over T1 equals to P2 over T2, where P1 is initial pressure, P2 final pressure, temperature, initial temperature, final temperature. So if I combine my Boyle's law, my Charles' law, and my pressure law, if I combine the three, it's going to give me the combined gas law or the general gas law. So that brings us to the general gas law. It's going to be, so general gas law is going to be P1 V1 over T1 equals to P2 V2 over T2. So whatever you are asked to find, you make it the subject of formula. So P1 V1 over T1 equals to P2 V2 over T2. While for the ideal gas equation, so we're done with this. For the ideal gas equation, the formula is given as PV equals to nRT. PV equals to nRT, where P is your pressure, V is your volume, then you have your N, you have your R, you have your T is your temperature. Your N is the number of moles of substance, while your R is a constant, gas constant. A quantity of gas occupies a certain volume when the temperature is minus 73 degrees Celsius. So that means our T1 is minus 73 degrees Celsius. Occupies a certain volume. So we do not know the certain volume. So this T1, V1 is unknown. And the pressure is 1.5 atmosphere. So your P1 is 1.5 atm. If the pressure is increased to 4.5 atm, P2 is 4.5 atm, and the volume is halved. That means the volume is now half of what we have initially. So I can write half here as my V2. Since it is half of the initial, I will represent my V1 as 1 centimeter cube. So look at what I've done now. I'm not placing this, I'm not saying half of X and X. No. You put this as 1, put this as half. Now, what will be the new temperature of the gas? So our T2 is what we'll be looking for. So we'll be able to sort V1 and V2. So what we have to do is let's look at the formula. With these parameters, we're going to use the formula P1 V1 over T1 equal P2 V2 over T2. That is the combined gas equation. We are to make T2 the subject of formula, we cross multiply. We're going to have P1 V1 T2 equals P2 V2 T1. We are making T2 subject, so we divide both sides by P1 V1, P1 V1. So T2 is going to be P2 V2 T1 over P1 V1. P2 is what? 4.5. V2 is what? Half is 0.5. Now we have to convert this temperature to Kelvin first. So how do you convert to Kelvin? Your T1 will be what? Minus 73 plus 273. that will be 200 degree or 200 Kelvin. So that is what we are going to use as our T1. So our T1 is going to be times 200 Kelvin divided by P1 is what? 1.5 times V1 is 1. So by the time we get our answer for temperature is going to be in Kelvin, then we convert it back to Celsius. So our T2 is now going to be this divided by this will be 3. 3 times 0.5 is 1.5 times 200. That's going to be 300. 300 Kelvin. So convert it to Celsius. You know, X degrees Celsius plus 273 will be equals to X Kelvin. So this, to find the Celsius, this will come here. X degrees Celsius will be X Kelvin minus 273. So converting this Kelvin to Celsius, X degrees Celsius will be 300 Kelvin minus 273. If we remove 273 from 300, our X is going to be 30. It's going to be 27 degrees Celsius. In the option, yes, that is the answer to the question. So that is how to solve a question on the general Gauss equation.